So it's actually, I mean, it's the same game to an extent in the sense of when you're predicting images and when you're predicting text, like it's just vector. It's just numbers, right? Like to us, that looks very, like a very different thing, but it's not. There is some slight nuance there that in like diffusion models, you're adding noise. And then so if you keep adding noise, that is probably random noise or pseudo random noise. And does that random noise change? So there's like slightly different problem there, but you can make the noise deterministic. So that helps on that side.
Did Bittensor, because you're a PhD in this space, how did Bittensor change your perspective on AI, if at all, in general?
No, it really did. It really, really did. And I think the first one was this when we set up gradients and we were watching like the evolution of miners, right? So we can't tell exactly what they did, but sometimes they would upload their configs. And inside their configs, you could see things change. And one of the things that they couldn't hide was that they were using something called RS LoRa, which is like rank stabilized LoRa, which essentially says that there was this extra parameter that we needed for LoRa training. We don't need that anymore because we've got this other version of LoRa that you don't need this extra parameter, which was great. And they said, well, what do we do with that parameter that we've got rid of? We'll just set it to 1. It doesn't matter. It's like academic. But then we found that miners started doing that. They were following the academic paper, but like very soon they were doing something completely different and they were doing much, much better. So I already knew this before, that academic work is mostly flawed and it's just like Bittensor. We are miners trying to get academic papers accepted, and we will find exploits, we will find ways of wording things. And that's not to say that like PhD researchers or researchers in general are nefarious and they're just trying to get their papers, but it's like we all work within incentive mechanisms of life. And if that's the incentive mechanism you set up, it's highly likely that people are going to maybe not explore the edge cases that Bittensor miners, when they're actually trying to find solutions to the problem, actually go out and find. So the first is like, the research don't read a paper and go, oh, this paper is correct. It doesn't matter where it's published. 9 times out of 10, the work in the paper, there's some edge cases or there's some things they've missed or they've sort of focused on one area of research and that doesn't apply to another. That all these kinds of things are true. But the other is just I find that now people ask me like what I do. Like I don't really say, oh, I do research. I say I do engineering. And I know that sounds silly, but you find that the best people within the Bittensor ecosystem, in my opinion, are engineers first and researchers like as a second thing, because it's like when you see the hunger of subnet developers and of miners, and it's pure in computation, they don't need to, understand what a rank stabilized LoRa is. They just know if I turn this one up, it works better, and why does it matter? And it's when you're trying to solve a problem, do you need to know everything about the ins and outs? Of course, there's some space in that. There's some value in it. And I don't want to say like research is dead, and it's not. It's super important. It's just for me, like found this newfound appreciation for the builders, and like, if we were hiring a new dev to join, I would hire someone that has built a load of stuff way over someone who's published loads of papers. Even though when I started this journey, I would have gone the other way. With people with PhDs, we're very important, and we don't, like we focus on one particular area and we've allowed to explore ideas, and that's great. We have some value, but I think the real value is in people that build stuff and that can ship it and that think about edge cases, and like that I value that skill a lot as a result of Bittensor. Yeah.
And this comes from a man that got a paper accepted to NeurIPS, which is like the most prestigious AI conference, and then you're a reviewer for them as well.
Yeah. Yeah. I mean, even, I don't know, it is important, and like sharing research, and obviously some of the best work that has ever come out of AI has been published in NeurIPS, has been published in ICML, has been published in these places. But we kind of in the field noticed that there's kind of been a bit of a problem, that we've had like an exponential growth in interest in AI. Loads and loads of people are jumping into the space, which is great, but there's only a very small pool of reviewers and of quote unquote experts. And of those experts, how many have actually worked in LLMs? How many have worked in this space? It's kind of, I think that there's kind of been a bit of a problem with the review process with AI and stuff like that. So yes, all those things are good and they're great medals. I get to call up my mum and go, yeah, I'm a reviewer for NeurIPS, and that sounds super important. And it is, like, I really take pride and value in doing those things, but I don't think they translate that well into the real world, is basically what I'm saying. Like they are a value, they're like a little bit of a sticker, but I think like I'm more proud of what we built with gradients by a long, long way. Don't get me wrong, I love my PhD work. It was cool. Like I really enjoyed it. We did some really amazing stuff. So glad I got to go to NeurIPS and experience that. But I'd pick working in Bittensor and actually working on decentralized AI any day of the week, because it's real, it's fun, it moves way faster.
Do you think the speed difference is because the PhD world, the traditional world, values more like changes that are closer to the norm rather than like drastic changes?
I think, actually, I don't think that's the case. I think actually, the research community does really value drastic changes. It's just the problem of trying to persuade everyone that this drastic change is of value is very, very difficult and takes a really long period of time, because you can't just say, oh, this optimizer you've done is no good, we should use this one. You have to then test it out on LLMs, vision, object detection, you know what I mean? Like, and then have some sort of theoretical framework as to why it's a thing. I remember, like, during my PhD, I spent maybe 2 years trying to publish that NeurIPS paper. 2 years of my life just for one paper, and the work hadn't changed. At the point of like getting the work done was maybe 3 months in, and then I spent 18 months rewriting the paper over and over and over. And there's value in that. I don't want to, communicating science is a skill that I learned, and it took a long time. But in the BitTensor world, like after the 3 months and you got the thing and it worked, it would have been out there. It wouldn't have taken another 18 months to kind of persuade people that it has value. You would have seen the value through, how did miners perform? What's the translation to in real world results with customers, things like that. So I think the speed, the speed is definitely different, but the attempt at innovation, I think, is probably the same. It's just that the speed is like you're held back by rigor, and rigor is important in some spaces. But is it that important? For real world, I'm not sure. Testing prod seems to work for most of the subnets in some way.
Test and prod is very popular in BitTensor. Let's get into your subnet now. Gradients. Subnet 56. Let's start high level. What are the miners, validators? What's the dynamic there? I know you recently have a change, but what's the legacy system first?
Yeah, so legacy system is essentially you have pre-trained networks. You have networks that have already learned language, so they understand the semantics of basic English or basic Chinese or whatever it is. But then there's that other layer that comes later, which is, okay, great, you know language, but can you answer questions on stuff that I care about? Can you understand my product database? Can you act like Donald Trump? Can you, whatever it is, like there is a level of specialization that needs to come after that. And so all of the chatbots that people use, they are not just the basic pre-trained network. They have like instruct training and reward function training that comes after. Gradients is that bit. So we essentially take something that has a base, so we don't have to spend years and years and trillions of tokens in order to get it to understand language, which is a thing that takes a lot of time. Gradients is then, right, given that model, give me any data set in the world, as long as it has some reasonable format. And gradients will say to miners, hey, listen, miners, here's the data set, here's the model, here's how long you've got to train on it. Go get me the best trained model that is still of the same architecture, starts from that point, and understands this data better than any other of the miners models that has been given the same task. And so that encompasses pretty much all of Hugging Face, or it does encompass all of Hugging Face. We started off with just instruct, which is like question answer. We then added DPO, which is like a reasonably more recent technique that says if humans prefer certain answers over others, basically. And we say to the model, hey, listen, I want you to more likely produce this answer than that answer. There's lots of data sets that are like this. And then finally, there's this GRPO, which is to say, I've got some reward functions. So here's some input text, and I want you to produce an output Y, and I'm going to give you more points for this kind of Y than that kind of Y. And so there's all kinds of different reward functions, all different kinds of data sets for DPO, and there's infinite number of data sets for instruct, and gradients covers all of those. And miners are essentially taking this data set model, time period pair, spitting out a model at the end of it. We also have diffusion, which is here's a base image model, and I want you to tune it given a few photos or a few pictures so that it produces more of a particular style. So we could have like Donald Trump funny photos that are cartoons. And if you train on, say, 10 photos of Donald Trump that are funny, this thing will just keep spitting those out. And miners have to go and get as close as possible to a ground truth of that. And what validators are doing, or the validator is doing, is essentially saying, okay, well, I'm going to keep some of this data from the training set that you don't know about, and I'm going to test you on that. I'm also going to test you on a little bit of the training data to make sure you've actually trained on it. And I'm also going to test you a little bit on some synthetic data, which is produced from the original data distribution. So in other words, it's going to be very similar to the data, but not exactly the same. And it's impossible that you've ever seen this because we are producing it in real time. And so we take is your worst loss out of those three compared to the worst loss of another -3 and the worst loss of another -3. And we do that. It's usually between 6 and 8 miners are given a particular task and they're sort of fight it out. To see who can produce the best model in the time period. And they're free to do whatever they want. That's one of the things that when we started Gradients, there was a little bit of a, not pushback, but kind of I see about that with the community thinking, we were kind of one of the first subnets that said, look, we're not going to even there's no constraint here. You do whatever, it's not that you have to run with these parameters and we're going to check that you've ran those parameters or that you've ran this, this temperature or anything like that. It's just a case of you just give us the best model for that data, that model and that time period.